Good morning. I'd like to introduce you today to our Edge Finisher EF-2000 model. This is a little bit different than our tabletop model in that the capacity that you can put through this particular machine is up to 2 inches thick, as opposed to the tabletop, which is 3 inches. Now, they're both production models, and they're both can withstand constant use throughout the day and throughout the week. So they are heavy-duty production machines, but as I say, this gives you the added capacity of going up to 2 inch thick. So if you really need to do 2-inch blocks or larger sheets, you have the advantage of being able to mount a longer sheet on longer rails here, and you have supports as well. Okay, so these can be adjustable anywhere, in, out, up, down. We can even probably make these pipes even longer if you need to customize a little bit. So basically this machine does pretty much what the smaller machine does. It's going to remove about 20 thousandths worth of material per pass, and it should take most saw cuts right down to a clear finish, as long as the saw cut's a fairly decent shape. So it's going to eliminate a lot of sanding and scraping and whatnot that you might be doing now, and this will, in one pass through, give you a finished product. Okay, what I'd like to do now is actually show you a sample that's run through, and we're going to do it with masking, and you can see that the edge here is fairly saw cut. Okay, and I marked it here so we can see it go through. What I'm going to do next now is turn on the dust collector, which is just a regular shop vac. That's all you really need for this particular unit. Then I'm going to turn on the machine, and you'll see me come back over here and pass the part through this way. Okay? Okay, here is the sample. But I'm ready with masking first. Okay, now if you take a look, you see we just finished this edge. This is the edge that was saw cut. Here you go. Sometime with masking, you'll get glue smears on there, as you'll see, sort of like in little half moon shapes. As far as the cut's concerned, they're very easy to wipe right off, and you get a nice clear finish just like this. Next, I'd like to show you, okay, what we have here is a 2-inch sample, and I'm going to pass it through the machine so you'll be able to see it. Unfortunately, it's not saw cut, but this will give you a pretty good idea of it passing through and what you can expect to find on your sample piece. So let me turn the machine on. And there you have it. These parts are all stackable, so if what we really want to do is run a couple pieces at a time, we can. There is a certain limit. In other words, you won't want to do like 8 pieces or 1/8 because the quality will start to deteriorate as you get towards the breakout side of the cut, which is going counterclockwise. But if you want to put 2 or 3 pieces like this through together at the same time, that's fine, and you'll always get a good result that way. Now, as I said, what we're doing is we're actually removing 20 thousandths worth of material per pass. And it's generally predicated on the difference between the rail heights. The rail heights are actually staggered. So the outfeed rail is actually a hair taller than the infeed rail by about, say, 15 thousandths. So what we do is we boost up the cutter so it's cutting a few thousandths more than the difference between the rail heights. And that way we can go through, we won't hit the back rail, we won't create a step on our part, we'll get a nice, clean, even, smooth finish. Basically, as far as electrical requirements are concerned for this machine, it's 220 volt and it is a 3-phase machine. Okay, so it is a 4-wire 3-phase. Generally what we do is we ship it with a twist lock plug on it. You can put any plug that you want on it as according to your shop needs. It won't invalidate the warranty or anything of that nature. Now, the cutters themselves that we're using are actually comprised of two different inserts, okay? We have a natural diamond and a polycrystalline diamond. The polycrystalline diamond is used primarily as a roughing tool, all right? And that takes the bulk of the material away, and it's also the very first cut from the positioning in the hub itself, which I will show you in a little while. And then the natural diamond is staggered to be a few thousandths above the polycrystalline diamond. And what that does is that comes through and makes a very fine swipe, and that's where you get your clear finish. And all this is sitting on top of a spindle that's running at about 24,000 RPM. So we're going through pretty quick and we're making a nice cut. We're only cutting on one particular side of the cutter, which is the infeed side right here. Okay, by the time the part reaches the outfeed side, the cutter is now going to be underneath the part. Okay, so we're only going to have one cut, and that way it helps save wear and tear on your diamonds, and you don't have a chance of getting drag marks and whatnot on your part. Okay, so what I'd like to do now is actually open this up, show you the cutter that I just talked to you about, and then we're going to go through and show you how to set up the cutter on the machine. And I'll show you a basic thing like when you buy the machine, what you have to do as far as installation is concerned, which is a snap, okay? It's going to be very easy, but and as soon as I go through it, you'll see for yourself just how easy it really is. So first thing we want to do is we want to open up our arms here, okay, the belt feed arms. And what I'll do is I'll swing these out. Now you got a good look at the belt feed from both sides. And now here we can see the cutter in the center, okay? And as you can see, it's got the two inserts on it. You have a natural diamond here, and this is the polycrystalline diamond. And this is the surface right here. This is the area in which the cut's all actually taking place. We really don't want to have anything happening over here, okay? And what we do to that effect, besides having the staggered rails, is we have the spindle itself is actually ground on an angle downwards like this to help facilitate this cutter not cutting on this side. Okay, what we'd like to do now is actually show you how to do a setup of the tool itself. So what we want to do is make sure, besides having the spindle nice and clean, is that the cutter itself doesn't have any chips on it. Because what could happen is these chips you see here, this is probably a thousandth or two, and that can affect your cut if you have it. So you want to have this sitting as flat as possible. So what I would do is come over, place it on the spindle. Okay, and we can go ahead and put in the 4 screws. And at this point, we want to be really careful about how we do this, because the natural diamond, when it's sharpened, is lapped to a very fine, almost burr-like edge on it. And it doesn't take much to pearl it over. And if that happens, what the result will be, you'll have a very dull cut, and you'll be able to see it in the part as well. So we want to be very careful screwing these in, that we don't nick the diamond or tap it with a wrench or let anything fall on top of it like an indicator, because that could very easily damage the edge, and then you won't get the clear finish that you need. Okay, so I got those snugged in a little bit. And on the side here, if you look carefully, you'll notice there's a hole. And it's not these little drilled out marks that they use for balancing, but here's a hole that actually runs into the part. And what we can do is put an Allen head wrench right in here like this, bring it up against the side here. And now we got the cutter immobile. We can tighten up these screws. Now we're all set. Okay, so now the cutter's installed, but we have to make sure that we have the correct height here in order to get a proper finish. If we're too low, by even a couple thousandths, what we can do is we can end up hitting this rail, creating a step. If you're too high, you can end up getting a cut towards the back, and it'll show up as a little mark as well. So we want to try and get it within a couple thousandths of the difference of these rails. If I were to take my indicator, okay, and as you can see, it's goes around 100 thousandths. Each one of these marks is a thousandths. Okay, we can put it on our infeed rail right here. Okay, this is where we're going to take all our base measurements from. And every cutter for the EF-2000 is going to be set to the same height. And what we set it to is 0.240. Okay, that's 240 thousandths. And what that tells you is the top of the tallest diamond, the natural diamond right here to the top of this hub, is 240 thousandths. So this gives us a good reference in which to set this part up. Now if I come over here, and you probably only have to do this really once so you know what the difference is. So now with this indicator, what we're going to do is we're going to bring it over here, make sure our point, we want to get it as close as possible, make sure our point is on the in-feed rail, and what I can do is adjust by loosening this up. This is just a lock pin. Now I can turn the rim of this and line it up with the needle till it's at 0. Okay, now we got our base measurement right here. Okay, so what we can do is now is take this, lift up the needle, drag the base over, keeping it on the in-feed rail, and just bring it over to the out-feed rail. And this is going to give me a reference measurement. Okay, in this particular case, the difference between the rails is 18 thousandths. So I probably want to shoot to set up this cutter for like 21 thousandths to get the best result. If you go too far, like 25, you could do some extra cutting on there, and it could show up as a mark too. So you want to be careful about doing that. Okay, so now what we want to do is, now that we've established what the difference is between the rail heights, is what we're going to do now is bring it back over to the in-feed rail and zero out again. And now we're going to come over and we're going to start taking a measurement on the actual cutter itself. So if I bring the needle and drop it down to the top of the hub, okay, what we'll do is we'll see what kind of height that we got here. Okay, so looks like we're off a little bit here, so we're going to have to make an adjustment. So what we'd like to do now is actually go in and show you how to make the height adjustment on the cutter itself. So what I'm going to do is I'm going to come over here and I'm going to open the door up. You have to use a screwdriver to do this. It's a safety feature. Okay, and you're probably going to want to make sure that the machine is off. So just flip the main switch off. Now what we can do is we can make our height adjustment. All right, now what I want to show you in this cabinet here in regards to adjusting the height, and I'll show you a few other things about it as well. So the first thing that we need to do now when we go to adjust the height is we need to take the tension off the belt. And how we do that is right over here with this handle that's on this crank. Okay, and if I turn it this way, which is kind of clockwise going towards the back of the machine, you can see that we're taking tension off our belt now. So this will allow us to actually go to the spindle, loosen up the clamp collar on the spindle, which I'm going to show you independently of the machine because it's very hard to get a good angle on it to show you while it's in the machine. But once we loosen that up, we'll be able to turn the barrel here of the spindle and raise or lower the height of the cutter, okay, and then lock it back in place. So now that I got the belt loose, okay, what I'm going to do is I'm going to come over, make sure I'm still set up on top of the cutter here. Okay, so now I'm going to go over after we've loosened our belt, okay, and I'm going to bring this over, just double check, make sure where we are. And you can see I go around 100, 200, 210, 220, 230. So I'm way off here. I want to back it off a little bit. Probably about 7 thousandths. And how we're going to do that. Okay, so what I'd like to show you now, because it's a little easier on our camera, and we can show you a lot easier actually out here, is the spindle itself and how we're going to make the adjustment. As I alluded to, it has a lock collar, as you can see right here. It's a clamp collar. It clamps around the threads. And it's locked in place by these 4 screws here, which are 1/4 20s. So if you take a wrench and just loosen them a little, you don't have to take them out. In fact, you don't want to take them out. Just get them a little loose. Okay. Now what you can do is once they're loose, you can see the barrel of the spindle now elevates up or down. And then once you get that in place, what you're going to want to do is just lock them up again. Okay, just like that. All right, so now I'm under the machine here, and we've got the spindle already loosened up and we're ready to go ahead and make the correct height adjustment. And just to reiterate, what we're doing is we started out on 0 here. You see I went around once, 100 thousandths, 200 thousandths, 210, 220, and we're about 226, 227 I'd say right there. So now, as I say, the spindle is loosened. What I want to do is I want to bring it upwards a little bit. Okay, let's bring it right around to the 80 there. Okay, because we know from previously that this cutter height is set up to 240. And if we go around twice on this dial, is 200 thousandths plus another 40, which would put the arrow on the 60. You would be dead level with the rail. So if we go 280, or in other words, a depth of 220, we now have 20 thousandths worth of this diamond above the in-feed rail, which is right about where we want to be. And when we go ahead and adjust the cutter and tighten this back up, you want to maybe leave yourself about a thousandths worth of wiggle room here, because as you tighten, you may notice that the needle would creep a little. Okay, the first thing that we'd like to do now, before we go ahead and button this up, is to show you pretty much what we want to have as far as belt tension is concerned. When you go to crank it back up and put tension on it, you want to have just a little bit of give, just a little bit, like a fan belt in a car. Okay, you don't want to have it too tight and have it pulling this way against the spindle, because at 24,000 RPMs and you're pulling on the spindle running through the bearings there, eventually you're going to wear a groove into it and then the spindle's going to go bad. So just give it to the point where it has a little bit of flex in it. Okay, like that, and you're good to go. And what we'll do is we'll go ahead and we'll shut the door up here, and I'll close the top up, and then we'll show you how to make the adjustments for the proper width of the material. Okay, so we got the door shut. Let's go ahead and get these belt feed arms back in position. Okay, just put them in right until they hit the backs of these screws, the lock screws. We'll go ahead and just tighten them up. You're going to want to make sure you're tight. You don't want the part forcing these things open, because they actually have a couple trigger fingers on them that connect to a couple push button switches underneath the table here. So they'll push them in, and what those push button switches are, they're actually safety devices, similar to what you saw on the door here. If this door is ever open, the machine won't run. Same thing with this. If this is ever open, in other words, the switch is up like that and the finger's off it, okay, it won't run. So if this thing ever opens on its own, like somebody forgets to tighten it down and you start running a piece through and it opens up, it's going to stop it. All right, it's just a safety feature, as well as the emergency stop here and the stop on the side. So now we've gotten the machine set up to the correct height, and we're about ready to make our first cuts. So let's go over briefly how we're going to adjust for the size of the piece. Up top here, you'll notice these red handles and these little levers in the holes. Okay, this is actually used to control the opening here between the belt feeds on both sides. So what we're doing now is we're actually bringing the two belts closer together. Okay, and what I want to do is I want to get it set up so I can basically almost rest the material on top of the belt and have a little bit of room back and forth like this. So when I put the part in, it will clamp, but it won't be so tight, okay, that it'll force it to move or squeeze it upwards or anything like that. We want to have just a nice firm pressure keeping it against the rail. And once you get this locked into place, you're going to be good until you go to a different size material. Okay, so as you can see here, we do have numbers along here, and these are just basically reference points. They don't really stand for any form of measurements, but if you know that you're getting a great result by having this one set on 3 and this one set on 2 for this size material, you can copy it down for quick setup later on if that's the way you want to do it. But it's just as easy to eye it up this way. Okay, all right, so now what we want to do is we want to come over here, and now that we've had it all set up, we got the correct height, we got the correct pressure adjustment, what I want to do is show you basically how to turn it on, how we control our speed, which is actually something that you will do depending on the type of material that you're running through, or Also the type of cutter that you're using, which I'll briefly go over in a little bit. All right, so now what we're doing is we're looking at the control center right here. Okay, you have, as you can see, the emergency switch up top, but you also have another emergency or just a common stop switch right here. This green button is actually our start button. And then this toggle here, this is to control the on-off for the feed motor. And this here is the speed control dial. What we can do is we can set it to any speed, generally variable from 0 to about 12 to 14 feet per minute if I have it maxed out, okay? And then of course the main on-off right here. Generally when we're cutting now with clear acrylics and we're using a diamond tool, we're going to want to tend to keep it on the lower end of the dial here. And the dial is actually set up to show you from 1 to 100, okay? And if I have it set for clear acrylics at about 30, that's roughly going to equal about 3 maybe 4 feet per minute, which is appropriate if you're cutting clear acrylic with a diamond tool. If I was going with another tool, which I alluded to a little earlier, such as a carbide, I would probably want to run this almost maxed out, like about 10 feet per minute to get your best finish. You have to use the right tool and the right feed speed on the right material to get the right result. So now that we pretty much got it all set up, we're going to just go ahead and start the machine up, and it's as simple as. Okay, as I mentioned a couple times already, is that we have different cutters that can be used with this machine as well. So we're not just limited to getting a clear finish off a diamond. We also have tooling which will give you a satin or a matte look as well with a carbide. And this is going to give you the same flat edge, removing the same amount of material as a diamond tool. But as I say, it's going to give you that satin finish, which is really, really good if you're doing something like gluing a lot of parts together. Because you know when you hit it with the glue, what's going to happen is when the glue cures, it's going to come clear anyway. So you're saving a lot of wear and tear on your diamonds, and you're using a carbide, which is much cheaper both to buy and to resharpen. And you're giving yourself the same flat base edge to work from. And now you have something that you can glue. It's going to be clear just the way you wanted it if you were going to run it with a diamond. Or if you want to leave the edge, which is very attractive on its own, you can do that as well. And alternately, it's also a very quick and light buff to get to a clear finish from a carbide anyway. What I have here now is a carbide cutter, and it's got 4 teeth in it, as you can see. We have 12 wings total, and these come in 3 different flavors. We have the 4-tooth, the 6-tooth, and the 12-tooth. And generally, if you're tending to run a lot of extruded material, you're probably going to want to use like a 4-tooth cutter like this if you're doing a satin look. A 6-tooth would be like a good general all-purpose cutter, and a 12-tooth works great with cast material. All right, and what they do is they mount pretty much the same on. There's actually a little cutter base that it sits on. You would mount it on, and with these particular tools, you can actually indicate off the tips if you want. Okay, so you don't have to go to any reference measurements or anything like that. You can just put it right on the tip, make the same adjustments, and you're all set to go. We're removing the same amount of material. So I just wanted to briefly cover over this, and I might also add that a lot of times when I go into shops and I tell people, well, we have these cutters that do a nice satin look, a lot of times people tell me, well, I got routers that can do the same thing. But generally, once I put this on and show them the quality of the satin finish, they immediately want to get one of these, and they're telling me about jobs that they have that they can run with it. So it's something that's very interesting to look at, and I think most customers will really like. So now you got the machine and you want to go to set it up, and there's really very little that you need to do as far as setup. It's not a very technical process. What you're going to need to do, besides setting up the cutter for yourself, which you've gone over, is we're going to want to put on these rails. Okay, these are the only things that really don't come assembled on the machine. The turnbuckle itself will be attached up here when you get it, but you're going to want to go through and lag it down to the top. There's 6 screws here, 3 on the other rail, and once you get that set up, go ahead down here and attach the bolt and nut through here so that the turnbuckles situated between the rail and here. And we're ready to go ahead and get this thing set up for straightness. All right, so now to get our straightness adjustment, what I got here is actually a machined straight bar that we bought, I guess probably from one of our local supply companies. And if we go ahead and put it on the rail here like this, okay, we can adequately gauge how straight this rail is. And I'm going to come over here for a sec. And I'm going to show you that the way I have it turned right now, it's actually not set very well. You can see the bar is kind of wiggly. You have a little bit of a gap right here. And I really want to see it nice and straight from here on out. And we don't want to have it go like this, feeding it in and then shooting it upwards. We want to have this go as straight as possible. So now, as I say, we got ourselves a little gap and we got to adjust this to get this straight. To go ahead and get that straightened out, what we're going to do is we're going to make an adjustment on our turnbuckle. It has two nuts here, okay, to lock this in place. So what you want to do is just loosen them up, back them off a little bit. And now we can turn our turnbuckle, okay, which is going to make an adjustment. And if we were looking up here where the rail and the straight bar are, we can watch as I turn this. You can see that the straight bar is now, the gap is closing and it's now sitting nice and level right here where the machine is, okay? And that should be pretty much all along the length of the part, but we really want to make sure it's nice and straight here where we feed through. You can also see that it's not quite as wiggly anymore. You can almost feel it firm up. Once you get it into this position now, you can go ahead, bring these nuts up like this. You're probably going to want to hold the turnbuckle a little, and then just get your adjustable wrench and tighten these up in the spots. Double check, make sure you didn't move anything, and you're ready to go. You would just repeat the same process on the other side to ensure that the outfeed rail is straight and level, and you're ready to go. Installation's as simple as that.